All right, guys. So we're going to talk about this real life, real world example, exploring volume with fun sized cans. And so, first, I have to explain and diagram and give you just an image. So, this is an image of a Voss water bottle on the left hand side. And on the right hand side, you have a Dole pineapple juice can. Now, we all know, comparatively speaking, how big a Voss water bottle is and how tiny a pineapple juice can is. So this can, I believe, is about 8 ounces, and the Voss water bottle is almost a liter, right? If not bigger than a liter, right? So for this activity, for this exercise, you have to think about your can being more of a Voss, a Dole pineapple juice size because of the radius. But I want you to pay attention to the dimensions and perspective of each can as we go through this, right? So the situation goes as is. The Fresher Drink Company is marketing a new soft drink. The drink will be sold in a fun-sized cylindrical can, which holds 200 centimeters cubed. Here are two suggestions for the radius of the cylindrical can. The first suggestion is the guy wants to design a can with a radius of 2 centimeters. The woman wants to design a can with a radius of 5 centimeters, right? And so, like I told you before, 2 centimeters and 5 centimeters of a radius. Now, you know the diameter is divided by two. So that means the Voss water bottle's diameter will be close to 3.5. And the diameter and the radius of this pineapple juice can will be closer to 4 and some change, right? So just comparatively speaking, that's the diameter of each one of these. So you can kind of comparatively see the sizes, right? And so the first question is each of these cans holds 200 centimeters cubed. Find the heights of these two cans. Now, if you look at the first page gives you two equations: equation for volume of a cylinder and equation for the surface area of a cylinder. Now, first question is pertaining to the volume of the cylinder, right? So we're going to use the volume of a cylinder equation to find the height of these two cans, and you want to make sure you put it on this page. The second question says, I want you to find the surface area of these two cans. Once you find the surface area of these two cans, you're going to write it here. The final question you want to answer, you're probably going to answer it on this slide, is this: are the dimensions of the cans suitable, right? And so somewhere on this slide, you're going to have to be able to say, is can one suitable? Is can two suitable? Explain if it is suitable and explain if it's not suitable, right? And that's the reason for the image of these two different water bottles and juice or containers or however we want to describe it. So the cans that you come up with may be relatively close to some of these numbers, but I just wanted to relatively give you an image of the kind of shapes you will be dealing with here, right? And so these are the things we have. I hope you guys have fun with this activity. We will move forward with another question in our next class, but let's have fun with this one. If you got any questions, please let me know.